Hello, everyone. My name is Lirong Shi, and I'm a rising third-year PhD in chemistry at the University of Michigan. My research mainly focuses on interfacial study for different applications using surface-specific spectroscopy. I know those words may sound too scientific or academic for some of you first hearing them, but my topic today will only be one of my research projects, and I will start from very common knowledge of science. And here is my topic. I don't have a title. This image is my title. I saw it for the first time when I was visiting University of Wisconsin-Madison. They had a special exhibition in their famous Chazen Museum of Art. Now it's your turn. Tell me, what did you see and what did you feel? I was shocked. First, by the fineness of the art. I feel science is falling behind and needs to catch up. Just kidding. We can see this picture depicts a woman in a dress covered by wastes, making me feel that we are all going to be covered by wastes produced by ourselves someday. It's almost intuitive for me to think about what I can do in my research field to help with the current disastrous situation. But first, let's check out how severe this situation is. As we all know, plastic pollution is one of the most persistent problems around the world. We can see in this chart, almost every continent has its share in plastics release. There are approximately 8 million tons plastics released into oceans globally every year. Plastic pollution takes a heavy toll on our environment and our health. But do you know, it does more than that. If you remember my title image, all kinds of wastes mixed up together, yet plastics can help these other wastes do more bad things, like holding a candle to the devil. What's going to happen if other wastes get involved in plastic pollution? Let me walk you through the process of their interaction with some diagrams. First of all, large plastic materials can go into the sea and break down into tiny fragments called microplastics, which is smaller than 5 millimeters. Due to their small size and ubiquitous distribution, they can go almost everywhere in the sea. Then other wastes from products like cosmetic products, the makeup stuffs, contain organic particles that can go near microplastics. They will attach to these small pieces of plastics, so-called adsorption, like unwanted parasites, and travel around to every corner along with microplastics. Chances are that they can be eaten by fish or other creatures. And unlike absorption, these particles are not simply taken in by plastics. They attach to plastics on the surface and can get rid of their rights once they enter the biological environment, like fish body. These organic particles pose great threats, and once we hunt the fish, these toxins will ultimately be in our kitchens and on our dining tables. They end up jeopardizing our health by causing diseases like cancer, or otherwise depositing in the seafloor and disturbing the balance of the environment. Now, have you noticed research problems that stand out? Yes, the problem lies in the interface. The organic particles adsorb and desorb at the surface of plastics, which means everything happens at the interface of the two. If we can figure out the story at the interface, we're likely to know how to deal with them. Therefore, interfacial study is important. First, I would like to explain what is interface. Interface is the boundary between two different substances or phases, like water and air, ships and the sea. An interfacial study is to learn the interactions between two things when they contact each other. We study what's happening at the interface. For instance, we study the interface between ships and the sea to understand how to protect ships from being eroded by the salty seawater. In this study, we will be looking at specific interface between organic particles, the green balls, and plastics, the pink line, to see how they interact with each other under different conditions. With experimental results, we can, on one hand, get ideas to design better plastic materials, which can make it more difficult for these organic particles to attach, eliminating the parasites from their source. On the other hand, we can improve conditions of waste handling by controlling the distribution of these particles. At last, I'd like to call for attention to plastic pollution and other wastes. Everyone can save the environment by doing a bit better in recycling and waste sorting. I want to emphasize that it is important to separate recyclable and non-recyclable wastes, especially plastics. When it comes to plastics, there are some common misconceptions that I'd like to point out. Not all plastics are recyclable or non-recyclable. I list some easy to be confused items here. Plastic containers are recyclable, while plastic bags are not. If we throw something non-recyclable into the recycling bin, we ruin the whole pack of recyclable wastes, as they will all end up in landfills. If we have a better sense of waste handling, we will be under smaller risks than having all the wastes mixed up together. Don't let the artwork be the new reality. Thank you for watching this video. I hope it's worth your time. Feel free to leave comments or questions if you're interested in learning more. Bye.